Hi everyone, this is Jenny, Assistant Professor from IT Department. For this lecture about soft computing, course outcomes of soft computing, I explain the biological neuron model and architecture of artificial neural networks. Course outcome 2, apply prescription the multi-layer feed-forward neural network models and classification problems. Course outcome 3, analyze learning rules such as Hibben learning, data rule, and back propagation algorithm. Course outcome 4, implement neural network training and testing procedures and evaluate network performance. Course outcome 5, apply neural networks to real world applications such as pattern recognition, prediction, and data classification. Syllabus Unit 1 Introduction to Soft Computing and Fuzzy Logic. Unit 2 covered neural networks, and Unit 3 Genetic Algorithm. Unit 4 Neurofuzzy Modeling, and Unit 5 Applications of Soft Computing. Now, Unit 2 Neural Network. Neural network, what is neural network? Neural networks are inspired by the human brain. Their development happened in the different stages. First, 1943 is a neural network history. First, in 1943, first artificial neural model developed by Warren McCulloch and Walter Peters proposed the first mathematical model of an artificial neuron known as it worked with like a simple binary threshold unit, that is input 0 and input 1. Foundation of neural network research in 1958 prescription and 1969 decline period. It founding reduced published book prescription. Neural network research slowed down like this. In 1986 back propagation revival. So propagation revival means introduce back propagation algorithm, enable training of multi-layer neural networks, solved non-linear problems like XR. The 1990s, practical used in handwritten recognition, used in speech recognition, applied in pattern recognition and finance. Then 2006 deep learning revolution introduced by Deep Leaf Network started modern deep learning area. Next, 2012 breakthrough in image recognition. University team developed by on MagicNet competition used GPU training, proved that deep neural networks are powerful. Then neural picked in the 90s hundreds of variants. Uh, let's say model of the actual brain, that there's a useful tool, but still some debate. Then numeric applications. Then debate for philosophers and constitutive scientists. Then comparison of brains and traditional computers. So comparison of brains and traditional computer means this is the basic unit. So basic into number of units. In human brain, basic unit is neuron. Number of units 86 million neurons. Element size 10 the power 6 million. 6. Then the element size 10 the power 9 million. Energy use 25 volt. Then energy in human energy what 30 to 90 volt. Processing speed is 100 hertz. Then computers processing speed is 19 the power 10 hertz. Then compute human parallel distributor and computers serial centralized. In human fault tolerant and computers serial centralized. Then human fault to tolerant, computers generally not fault tolerant. Learners yes, learners some. Intelligent conscious, usually intelligent conscious in human brain, generally no. Then biological inspiration. So biological inspiration means to make the computer more robust, intelligent, and learn. Let's model or a computer software hardware after the brain. So brain is made of biological neurons. Each neuron connects to thousands of others, forms complex network. Computer made of electronic components, CPU, it's available CPU, memory, input output device, work-based and stored programs. Then processing difference. Brain is works in parallel. Computer executes instruction one by one. Next, is neurons in the brain. So neurons in the brain. First of all, what is neuron? What is neuron? A neuron is the basic structural and a functional unit of the human brain and nervous system. Human brain contains approximately 86 billion neurons. Neurons are responsible for thinking, learning, memory, movement, sensation, like this. Then structure of neuron. Structure of neuron dendrites, branch-like structures, receive signals from other neurons, carry signals towards the cell body. Cell body contains nucleus, controls the functions of the neuron, process incoming signals. Then how neuron communicate? Neuron communicate through electrical and chemical signals. Electrical impulse travels through the axon and the end chemicals called neurotransmitters are released. Then types of neuron means sensory neuron, motor neurons, and internus. Important. Then learning in the brain. So learning in the brain. What is learning? So learning is the process by which the brain acquires new knowledge, skills, or behavior through experience and practice. It happens because of changes in connection between neurons. Then how learning occurs in the brain? So learning manually occurs through synaptic changes between neurons. Hebbian learning. So then long-term potential. So habit learning principles means proposed by Donald Hebb in 1969. Famous rule that is neurons that the fire together, wired, wired together. So meaning there's the meaning of two neurons activate at the same time repeatedly. Their connection becomes stronger. Then role of important parts in learning cerebral tracts like this. Then types of learning in brain, associate learning, motor training, conjunctive learning. Then perceptrons. So the diagram represent initial proposal of connectionized networks. Rochenbard 15 and 16 is essentially a linear discrement composed of nodes and weights. Then here in the Intel proposal of connection network means perception is one of the earliest neural network model. It is based on the idea that intelligence comes from connection between neurons. This approach is called connectionalism. Then this prescription was proposed by Frank Rosenblatt, developed in 1958 in of the first machine learning models. Design a pattern classification. Then diagram shows left diagram uh, that is I1, I2, I3. So three inputs, three weights, weight 1, weight 2, weight 3 weights, and theta threshold and O means output. So first which inputs is multiplied by its weight. That is W1 divided by I1 plus W2 divided by I2 and W3 divided by I3. So the total becomes sigma WI plus threshold theta. Then activation function. From this slide, in activation function equal to O equal to 1 if sigma YI plus theta greater than 0 otherwise. So if result greater than 0 means output is 1, otherwise output equal to 0. Then the right diagram shows a constant input 1 is added. That constant has weight theta, so threshold becomes base term. Mathematically, W1 divided by I1 plus W2 I2 plus W3 I2 plus theta of 1. So threshold is bias. Both diagram represents the same prescription. The next diagram about prescription example. That is the slide shows a prescription numeral example learning procedure. First one given in the diagram inputs, weights, threshold. Then first one prescription formula substitute a value 1 plus 0.3 minus 1 equal to 0.3. Then rules. So then learning procedure randomly assign weights between 0 to 1. At the beginning weights weights are random. Example 0.5 and 0. Here. Then present inputs from training data. Give input values 2, 1. Calculate output. Get output 0. Adjust weights to a desired output. Where learning rate, target output, actual output. Then continue training stop when no errors are maximum completed. Present inputs from train data, repeat stop, no errors are through completed. The next, precision training. So precision source, weight update rule. Weight update rule, W8 of T plus 1 equal to WIT of plus triangle W of T. Meaning now weight equal to old weight plus change in the weighting. That is a new weight equal to old weight plus change in weighting. Change in weighting means triangle Y of T equal to T minus 0, I O, T minus O, I of I. Where T means target, that is output. O equal to actual output, LA equal to input, T one is equal to error. So weights are adjusted based on error. Then in the T equal to 0, O equal to 1, W1 equal to 0.5, W2 equal to 0.3, theta equal to minus 1. So in the given in the values. So error. So first one we want to calculate T minus 0 equal to 0 minus 1. That is error. Then update W2, WT of T plus 1 equal to 0.3 plus minus 1 into 1. So 0.3 minus 1 equal to 0.7. Now weights after training, W1 equal to 1 minus 5, W2 equal to 0 minus 1. So theta value is now minus 2. Then final statement, net equal to 2 of minus 1.5 plus 1.0.7 plus minus 2. So we get 5.7. Then present in the input again, we would output is 0 is instead. Then how might to use a perception network? So, in the generally best to learn how to make classification. It's based on age, sex, chest pain type, resting, PBS, cholesterol diagnosis. So, to calculating 67, 1, 4, 120, some values are sent. So, the diagnosis, some condition less than 50 percentage diameter narrowing, greater than 50 percentage diameter narrowing. So, train network to predict heart disease of new patient. So, here is a calculator. Then prescription. So prescription can add learning rate to speed up the learning process, just a multiple with the delta computation. Essentially, linear discriminant prescription theorem. So if a linear discriminant exists, then separate the classes without error. The training procedure is guaranteed to find the line or plane. So here the graphical representation class 1, class 2. So class 1, class 2, n of eta equal to landing rate value between 0 and 1, then controls how much weight change. So small n slow landing, large and fast landing. So in the theorem, we have a 2D straight line and 3 class 1. This is straight line, class 2 is a plane. So Hyman diamonds are hyperplane. Then exclusive aura problem. Exclusive or XOR problem. That is what is first what is XOR? XOR is a logical operation of this rule. Output one is the inputs are different. Output zero is the inputs are the same. That is input A means 0, 0, 1, 1. Input B means 0, 1, 0, 1. Output XOR 0. If we will get output 0, 0, 0, 0, 1, 1, 1, 0, 1 and 1, 1, 0. Then it's called a problem. That is a machine learning, especially with a single type perception XOR cannot be solved. Some XOR data looks like then a graph 0, 0, 1, 0, like this. One is diagonally opposite, is diagonally opposite. So XOR is not linearly separate. That's the slide says XOR problem, not linearly separable. Then how do we solve XOR? We could, however, construct multi-layer prescription by adding one hidden layer nonlinear activation function. Then XOR is very historically important, means it's a layer with hidden layers, back propagation, non-linear activation. Thank you.